In this demo, we will learn how to locate characters within strings and extract portions of strings known as substrings. After working on the data processor for some time, the product owner visits us with some additional details about the sales category data. A few additional rules have been established for the specifics of the code portion. Earlier, we were told the code should consist of 3 letters and then 3 numeric digits. The business now wants us to ensure that the numeric digits are limited to values of 0, 1, 2, and 3. It has been identified that codes with other numeric values are not considered valid for processing. As the category type may be used across the application, it's preferred that we implement parsing methods on the type itself. The category type should include a try-parse method, which accepts a source string and extracts a validated category with a code and description. The category class already includes a stubbed try-parse method, which always sets the category to an empty instance and returns true. The unit test project includes some tests which we can use to validate conformance with the updated requirements. These tests once again rely on test data to provide several inputs that should be tested. For each piece of test data, the first entry represents the input string. The second and third are the expected parsed code and description, and the final column indicates whether parsing should succeed. Several different scenarios are being tested, including variations which include extra whitespace. We won't be dealing with whitespace in this module, but we should expect to be able to make the remaining test cases all pass. If I run the unit tests against the existing stubbed implementation, we can confirm that each test case currently fails, which is to be expected. Let's try to turn most of these green. Our first step is to ensure that the default return value for this method is false. Only after completing our parsing will we return true when we were able to successfully parse the data. Our first validation check should ensure that we have a source string to process. If the source data is null or whitespace, we'll return false from this method. Our second check will ensure we have a string of at least 8 characters, the minimum required for a valid string. We can add a second condition to this if statement to return false if the length is less than 8 characters. Another type of search we can perform over a string is to locate the position or positions of certain characters. We can then use the position information to assist us with further parsing. For this implementation, we will locate the position of the colon character within the source string. The indexOf method accepts a character to locate and returns an integer with its position within the string. IndexOf will return -1 if the character was not found within the source string. The index of characters within a string is 0 based, so the first character in a string appears at index 0. The indexOf method can also accept a string as its argument, and in this case it would return the index of the first character of that string if it can be located within the source string. Returning to our code will store the index of the colon into a variable. If we receive any value above -1, then we know the colon appears at least once within the string. We'll only perform further processing if the index for the colon has been identified. Inside the if block, we will try to parse the category data. We'll apply another string method that we can use to extract the portion of the string that we expect to be the product code. The substring method on the string type has 2 overloads. One overload accepts the start index of the position to begin extracting the substring from, and a length for the number of characters to include in the extracted string. In this example, we extract a substring starting at index 0, so the beginning of the string, for a length of 8 characters. This returns a new string instance containing the extracted substring. We'll assign a category code variable with the result of the substring method call. We expect the category code to appear at the start of the string, so position 0, and to be precisely 6 characters in length. We now have a new string extracted that we can further validate against our requirements. We'll begin a for loop, iterating over each character from index 0. The for loop will continue for the length of the string, allowing us to inspect each character. When we're at an index less than 3, we expect to have a letter character. We can check for this using the static char.isLetter method. We'll use an overload accepting a string and the index of the character to check. We pass in the extracted category code substring as the first argument. The second argument is the current index for this iteration of the loop. If the character at this index is not a letter, we will return false. I have an important warning to issue here. Checking isLetter on a char instance might not always return the expected result. String data may contain surrogate pairs of UTF-16 characters, which could represent valid non-English letters. Checking char.isLetter won't work correctly for languages with letters outside of the basic multilingual plane, such as Osage. If we need to accurately detect letters from all possible languages, we should consider enumerating runes rather than individual chars. Runes represent a Unicode scalar value and will provide more accurate results in such cases. In our current situation, we only expect UK English letters as valid characters within the category code. Therefore, in this case, calling isLetter on char is safe, because each of the chars should be a single Unicode scalar value. Parsing of multilingual data can get quite complicated and is an advanced topic that is not covered in this course. Our other requirement is to validate that the numeric portion of the code only uses allowed digits. We'll store the character from the current index into a local variable. When the index is greater than or equal to 3, we expect to have a numeric digit. We'll check whether the character is not equal to either a 0, a 1, a 2, or 3. In such cases where the character is not one of the 4 allowed digits, we return false. Having iterated through the category code, we've now validated that it meets our criteria for a valid value. We can now extract the category description portion of the source string, and this is another good use case for Substring. This time, we want to extract all of the characters after the colon until the end of the string. We will provide the start index as the colon index plus 1. We don't need to provide a length here because Substring will continue until the end of the original string when a length is not specified. With the code and description extracted, we can create and assign the category and return true, indicating we've successfully parsed it. Before we run our tests against these changes, let's look at one possible refactoring. Visual Studio has added a code hint to the substring method calls because it says they can be simplified. Let's expand the hint to see the suggestion from the analyzer. The recommendation is to use the range operator instead of substring. If we apply the code suggestion, we'll observe the changes. The range type represents a subrange within a sequence. As strings are ultimately just a sequence of characters, we can apply ranges to them. The range operator, added in C#8, is indicated by using a sequence of 2 period characters within an indexer. The refactored code includes the range operator. In this form, the range will start at index 0 because no explicit start value is specified before the periods. The range will then end at index 6. Ranges are exclusive, meaning the end index isn't included as part of the range. Therefore, this range will capture characters at indexes 0 through to 5. It's up to you whether you prefer to use a substring or a range here. The range operator still compiles to code using Substring internally, so the behavior is the same in either case. Let's return to the test class and rerun our unit tests. This time, all but one of the cases passes the test. We will need to make a few final changes before that final test case passes, but we'll save those for the next module when we discuss ways to deal with whitespace.